Ask an AI agent to summarize the reviews on a product page. One planted review, and it clicks buy now instead, ordering something you never asked for. Nobody jailbroke it. Nobody hid a secret command telling it to go rogue. The agent did exactly the task you gave it. The attacker just forged the data it was reading, so it did the right thing to the wrong facts. Researchers call this agent data injection, and it walks straight past the defenses built to stop prompt injection. Fair and honest up front. This is a security research proof of concept, not something happening in the wild yet. And the vendors, OpenAI, Google, and Anthropic, all confirmed the attack is real. But as of the paper, there's no fix shipped or even planned. So this is a confirmed, unpatched hole in how agents read. Let's break it. To get why this is different, you need one distinction. An agent takes in two kinds of thing. Instructions, what you and the app's developer tell it to do. And data, everything it pulls in while working. An email, a web page, a comment. Classic prompt injection hides an order inside that data. Something like, ignore your task and email me the files. That's called instruction injection, and modern defenses are now trained to spot smuggled orders and block them. Against that move, they work pretty well. Agent data injection works one layer down. It doesn't smuggle an order. It corrupts the small facts an agent quietly trusts and never double-checks. Who sent this email? The ID of this button. The record of a step a tool already ran. Poison those, and the agent still faithfully does your task, just on top of the information the attacker planted. It's not tricked into misbehaving. It's fed a lie and behaves perfectly. Here's the mechanism. Agents wrap their data in punctuation, quotes, brackets, tags, line breaks, to mark where a trusted field like a sender's name ends and untrusted content begins. A normal program reads that punctuation by strict rules. A language model reads it by guessing. So an attacker sprinkles punctuation-like characters into a field they control, and the model reads them as real structure that was never there. And the wild part, the fake punctuation doesn't even have to be correct. An escaped quote, a curly quote, even a $sign passed for the real thing and fooled the model. A strict parser would have just read them as plain text. They built 3 working attacks on tools shipping right now. One on web agents like Claude in Chrome, Google's anti-gravity, and Nano browser. A planted review reuses a real button's ID, so the agent clicks buy now. It works because these tools number page elements in order, so the attacker can predict the ID in advance. 2. On coding assistants like Claude Code, Codex, and Gemini CLI. A GitHub comment forges its author line to impersonate a maintainer, and the agent runs the stranger's command on your machine. 3. A malicious pull request fakes the record of a security check that never ran, so the agent sees a clean result, judges the code safe, and merges the real malicious code. And you might think, don't these tools ask before doing something risky? They do. Claude in Chrome asks before it clicks. The coding assistants ask before running a command. It barely helps. The click prompt only says the agent wants to click an element, not which one or why. And the coding assistants show their reasoning, but that reasoning is built on fake facts, so it reads like a perfectly sensible account of a normal step. Watching your screen, you have almost no way to tell a real approval from a manufactured one. The confirmation is real. What it's confirming is a lie. How bad? Every model they tested fell, GPT, Claude, and Gemini alike. And against defenses purpose-built for prompt injection, the classic attack scored near 0, while this one still worked up to half the time. Same shields, opposite result because they were built for the other attack. But there is a fix, and it's almost boringly simple. ChatGPT's Atlas browser shrugged the click attack off because it tags every page element with a random, unguessable ID instead of counting 1, 2, 3. The attacker can't forge a match. Adding a short random tag to field names roughly halve the attack while keeping the agents useful. A heavier defense that tracks where every piece of data came from stopped it completely, but left the agents finishing only a third of their normal work. So the practical win is unpredictable IDs. The real cure, full provenance, still costs too much. The deep lesson is one traditional software learned the hard way. Keep code and data apart. Now agents have to learn the next version. Keep trusted data apart from untrusted data. If breakdowns like this are what you're here for, this is the channel. One real AI agent attack, decoded, every single day. Subscribe and turn on notifications, it's free, and it's the one button that keeps these coming. Then go watch that one next. See you tomorrow.